Alright, here's the last lesson we're going to talk about for this week. We're going to talk about higher derivatives, so second, third, fourth derivatives, and this is going to be from Chapter 3, Section 7. You'll notice that the homework is different than what is on sort of like the printed, and I've crossed it out, and that's just because things have changed between last year and this year, and I didn't notice that when I was making the PDF. So make sure you've got this correct homework written down, and let's talk about some higher derivatives. So one thing that's really helpful here is the main thing when we think about higher derivatives is that it's the derivative of a derivative, meaning that if f of x is equal to y, this is just a fact that we know about function notation, then f prime is equal to d dx of y, which you'll notice, if we use the Leibniz notation, we are simplifying that to dy dx. You can just think about it like multiplication. Now our second derivative, so we would write that as f double prime, would be the derivative of that first derivative. So d dx of dy dx, and that gets written, if you remember, as d squared y over dx squared, and you'll notice that would also simplify with the Leibniz notation like that. So there's your second one. And this pattern will continue if we call something the nth derivative. So it might be tally marks if it's 2 or 3. You might have like the fifth derivative written like this. It's the same as d to the n y over dx to the n. So you might get asked this in a number of different ways, just depending on the different n value there. So you might get asked it with function notation or with the Leibniz notation. So let's find the first three derivatives of y is equal to sine of 2x. So this is a straightforward chain rule, and we're going to start by saying that f prime is cosine of 2x times the derivative of 2x, which is 2. Then finding the next derivative, we've got a coefficient, which is 2, back here, times the derivative of cosine, which is negative sine, of 2x, and then times that internal derivative again, so 2. And if you wanted to simplify this one, which I do, I'm going to write that as negative 4 sine of 2x is the second derivative. And that's going to make it even easier to find the third, which we take that coefficient, negative 4, cosine of 2x times 2 again. So the third derivative of x would be negative 8 cosine of 2x. So here we have our three derivatives, 3, 2, and 1. The next question's asked is, what is the nth derivative? And so when they ask for that, they're looking for a pattern. So let's repeat what those first three were. So we can see here we go from sine, cosine, sine, cosine, to negative 4, negative 8. If we continued on with this pattern, the fourth derivative would be positive 16 sine of 2x, because we'd create a negative when we take the derivative of cosine, and so on. So one thing I would love to have you notice is that when you're looking for an nth derivative, they're just asking for patterns. And the pattern I notice here is that if I have an odd derivative, I have cosine, and if I have an even, so fourth derivative, second, you can think about the function itself as the zero derivative, we have sine. So this tells me I might even make sense to write a piecewise function here. So I'm going to use this space over in the notes section, and I'm going to say that the nth derivative has one form where n is odd and another one where n is even. Now the difference here is that when it's odd, it's going to have cosine of 2x, and if it's even, we'll have sine of 2x. Sorry the writing's so small. Again, make sure that yours is a little bit more legible than that. The other thing we'll notice is that if I'm looking at cosine, it goes 2, 4, 8, 16, so we're looking at powers of 2. And because it goes positive, negative, positive, negative, this is what we call an alternating. And for that we use powers of n. And so what we say here then is that we have powers of 2, and that is going to be, I'm going to use the n as the variable there, because what I notice is that it's 2 for 1, 4 is the second, 3 gives us 8. So these are just powers of 2 here. And then it's alternating using, this happens every other. So what I'm going to do here is create another additional variable out here where I'm going to just multiply that by our power of n on the outside. I know this is a little bit messy because there's not a ton of space, but there is longer explanation in the PDF if you want to look at that. So these are our nth derivatives using our different tools. Now here we have an implicit differentiation function, and we're going to start, it's asking us to find our second derivative here for y double prime. So the first thing we're going to do is find y prime. And that's going to be, as we've done this one before, 2x plus 2y times y prime equals 0. Cancel out and simplify, and we get y prime is equal to negative x over y. And since we're looking for the second one, we then need to take the derivative of both sides again, and we're left with d squared y over dx squared. And then we've got a quotient rule here where I'm going to keep the negative on the outside, and then the numerators has a derivative of 1, and the denominator has a derivative of y prime. And so then I have our quotient rule, and if you remember correctly, y prime here is equal to negative x over y, and so I'm going to substitute that in. So now we have our second derivative, and I'm going to do a little bit of simplifying before I plug in this point. Oh, sorry, this should be a comma, not a decimal. So we have our x and y value for our function here. X is 3, y is 4. You could just plug in at this point, but there's a lot of negatives going on, and I'm going to simplify the multiplication and the negatives, and I'm also going to simplify by doing one extra step, which is to multiply both sides of my fraction by y. And the reason I'm doing that is that that's going to cancel out the denominator here when I multiply, and then here it's just going to make it a y squared, which is a little bit nicer to deal with. So then my second derivative is negative y squared plus x squared over y cubed, and then I'm just going to plug in my 3 and 4, and from there it's straightforward arithmetic. We've got negative 16 plus 9 over 64, which gives us negative 25 over 64 as the value of that second derivative. Let me know if you have any questions about these higher derivatives, and if there's anything I can do to help, put it in the comments, make an appointment, or send me an email. I'll talk to you later. Bye.